Thank you very much for the introduction and welcoming me here. And welcome to all of you to the nanoTalk about hydrogen and future mobility. And when I talk about future mobility, it's a broad topic. I mean, how do we get people from A to B in the future? And there's also still, that's also still a broad topic. And we have on the one side the social stuff, and also will we use artificial intelligence for driving, car sharing, will we use self-driving cars, public transportation, and all this stuff on the left side. When I talk about future mobility as an engineer, I think about the powertrain, and with this, the most common topic now is how do we get them CO2 neutral. So, for example, if you drive an average gasoline car, you produce 13 kilograms CO2 per 100 kilometers. So that's a lot of CO2. And there are approaches to reduce them with hybridization, or also approaches to really get CO2 neutral. And the first one that's always mentioned is the battery electric vehicle. And with this, you are CO2 neutral because you don't have direct CO2 emissions. And when you have solar panels on your house and you only drive short ranges, you are CO2 neutral. But on the other hand, this technology has also disadvantages like the short ranges in general, then the long refueling, or in this case recharging time, and for everyone to really drive a battery electric vehicle, you would need infrastructure with a whole lot of more renewable energy and charging stations. And this is very complicated. So the other possible opportunity to go CO2 neutral in the powertrain system is to go to fuel cell vehicles. And these vehicles have electric engines powered by fuel cells that are powered by hydrogen. And with hydrogen, you only get water emissions. So for the instant emissions, you are equally CO2 neutral than battery electric vehicles. Hydrogen itself is the most common atom in the universe. This means it's all around us, but not like pure hydrogen at the moment. So the technology of fuel cells is also very old. We have it like the first experiments happened in 1838. And for example, NASA uses fuel cells from the 1960s up till today as the main power source for their space programs. And also in transportation, like public transportation, there were first prototypes of fuel cell vehicles in the 1990s. So this technology was there about 30 years ago, and since then there was a lot of research on fuel cells and hydrogen production, but it had not has this hype. And this is simply because there are cheap and easy accessible alternatives like oil or methane gas, and they always kind of let the hydrogen hide itself. Also, hydrogen is very, it needs proper handling. To put it simple, it's a very small molecule, and because of that, it's very diffusive. So, and also it's very explosive. And when people think about hydrogen, their minds always blew up. Like they think about explosions, like for example the Hindenburg, or also a topic that's always mentioned is the hydrogen bomb, but which has nothing to do with hydrogen in the mobility sector at all. As I said, proper handling is needed, and today we can really do that in an amount that hydrogen is as safe as gasoline. So it's still relevant because hydrogen has, as I said, no direct CO2 emissions and a very high mass-specific energy density. You can see this here. Hydrogen has about, or even double the density than gasoline or diesel. On the other hand, the volumetric density of hydrogen is very low compared to liquid fuels. So this is a problem for a sector like transport, where you don't not only have weight problems, but also volume problems. But when you change from a conventional vehicle to a hydrogen vehicle, you don't have to adapt that much, as you have, I think, nearly the same range, nearly the same fuel price for one refueling, and also a similar refueling time compared to gasoline vehicles. So that's a very good advantage compared to battery electric vehicles. And also hydrogen is a chemical energy carrier. This means it can be better stored and transported than electrical energy, or more efficiently transported. On the other hand, the whole hydrogen process in the mobility is not as efficient as the battery or electric vehicle. But with renewable energy, we still are CO2 neutral. For this whole thing to really happen, so for hydrogen future mobility, we need the infrastructure though. So it's similar to battery electric vehicles. We not have the infrastructure yet, but we need it to go forward. And speaking of infrastructure, here you can see the move. That is the first hydrogen refueling station in Switzerland, built in 2016. And I will show you how we brought this whole thing of producing and refueling hydrogen to Switzerland. Here you can see this whole process from the start, from the production to a storage to the refueling. And we go through it from the start. We start at the hydrogen production, as I said. And in our case, we produce hydrogen with electrolysis. And this has an efficiency of above 50%. So it's still very efficient, but it's not that efficient as if you would use directly the electrical energy. And all our electrical energy is produced renewable. For everyone that is a little bit unsure what electrolysis really is, it's the process of dividing water into hydrogen and oxygen with an electric current, and also a membrane that separates the cathode from the anode. So in our case, it's a proton exchange membrane, short PEM. And this is the reverse process of the fuel cell. So in this case, you put electric energy inside of it, you get hydrogen out, and the fuel cells put hydrogen and oxygen in and get electrical energy out that fuel the electric engine. In the move, we have 180 watt installed electrical power electrolysis. This means we get about 2.7 kilograms hydrogen per hour out of this system. And when we have them, we need to store them. And as you see, it's not that easy, and this means this is because hydrogen has a very, very low density. When you have normal conditions and you want to store 1 kilogram of hydrogen, you would need 11 cubic meters for this. Or the other way around, if you would have a tank with 1 cubic meter, you could only store 90 grams of hydrogen. Our electrolyzer produces hydrogen at 30 bar, so we can reduce the needed volume a lot. But for vehicles, this is still too much volume. And so currently the trucks are using hydrogen at 350 bar, and the passenger vehicles use hydrogen at about 700 bar. And in our system, the highest pressure is 900 bar, because we fuel only because of the pressure difference from our tanks to the vehicles. And with this 900 bars, we can reduce the needed volume from originally 11 cubic meters to 0.02 cubic meters, means it's about 0.2% of the original volume. But not every material holds this pressure, especially with hydrogen. So we have composite material cylinders This means we have a polymer inlay and carbon fibers around them. And here you can see there are 12 tanks. 6 of them are filled with 30 bar and 6 with 440 bar. And we have our high pressure stage here. These are 20 cylinders with 900 bar. And this whole thing has about 7 cubic meters and 150 kilogram of hydrogen stored on this small volume just because of this pressure. As I said, we go from the storage to the refueling, but first we have another problem to solve, and this is the pre-cooling step. Because of this pressure change from this 900 bar in our tanks to our vehicle tanks that have a lower pressure, we have a heat development, and this can be up to 100 kelvins in one refueling. So our vehicle tanks can only handle about 80 degrees Celsius, so we need to pre-cool the whole hydrogen to minus 40 degrees before we can really put it into the car to avoid damage. And there are a lot of simulations and projects about this whole hydrogen refueling and heat development in these tanks. Now, from the pre-cooling to the fueling, we have, as I said, 2 refueling stations, or it's one. On the one side we have the 350 bar, and on the other side 700 bar. And with this setup we have about 5 minutes refueling time and sell the hydrogen for 10 francs per kilogram. In a normal passenger car they fit about 5 kilograms. And I really wanted to show you this nozzle here, because I think that's the most interesting part, because everyone always thinks it's like something strange or from the future, but it quite looks not that technically challenging. It has an infrared sensor in this around the gas channel, and when you couple it to your vehicle and you press here start, the whole thing first checks if the pressure is right, if the temperature is right, and if there is any leakage. And only if everything is okay, this whole process starts. And so you don't have to fear when you stand near a hydrogen refueling stations that something is going out and blowing up. As I said, this is the process we have in the move, and it consists of a hydrogen production, hydrogen storage, and the hydrogen refueling with pre-cooling. And now is the problem, this technology is very new, so this process or these technologies are needed, but every hydrogen refueling station has them to a different level or uses other process steps or other technology. So you cannot say every refueling station looks really exactly like ours. Some only have one pressure stage, and some get the hydrogen transported over a little bit of distance. And I say this is only the one we have, but the technology we have is really the one that is needed for hydrogen infrastructure. And currently there are 3 hydrogen refueling stations in Switzerland, and that is really not enough to have everyone to cover it with hydrogen. And there still needs to be this infrastructure built. And one of these projects that really looks out to develop or to introduce hydrogen refueling stations is H2 Energy. Together with Hyundai, they want to introduce 1,600 hydrogen trucks to Switzerland and build this refueling infrastructure. And if you want to look where is my nearest hydrogen refueling station, you can look at either of these maps. And when you really want to buy a new hydrogen or fuel, if you want to really buy a new fuel cell car, you now have to settle for one of these models at the moment, but I hope there will be more in the future. And when I say now future mobility, what I think about is I hope some of us can in the future drive with hydrogen, producing only water in this process, because it is a CO2 because it is a CO2 neutral alternative if we really implement this infrastructure. And I want to thank you very much for your attention. And if you want to know anything more about the move and all these projects we are doing around it, you can go to this website. So thank you very much and have a nice evening.
Thanks a lot.